Okay, well, thank you, Steve. I'd like to introduce Dr. Pierre Fogal VE3 Kilo Tango Bravo. He hails from Guelph, Ontario. Peter received an undergraduate degree in physics from the University of Waterloo, followed by a Master of Science and a PhD at the University of Denver in Denver, Colorado. Pierre's field of research is atmospheric composition determined through infrared spectroscopic study. In 2004, he was recruited to help with the establishment of Canada's new Polar Environment Atmospheric Research Laboratory, or PEARL, located at 80 degrees north latitude on Ellesmere Island in Nunavut. He's been the PEARL site manager since then and typically spends 3 months of the year in the Canadian high Arctic. Pierre was first licensed in 2000 as Kilo Charlie Zero India Golf Yankee, and still holds that call as an extra class operator in the United States. 10 years later, he received his Canadian license as VE3 Kilo Tango Bravo. Pierre's a founding member of the Eureka Amateur Radio Club on Ellesmere Island, a member of the Guelph Amateur Radio Club, and a member of the Contest Club of Ontario. And so Peter will be speaking to us today on atmospheric science and amateur radio, the PEARL Laboratory monitoring the Arctic atmosphere, and VY0 Victor Yankee Zero Echo Romeo Charlie, the Eureka Amateur Radio Club. So I'd like to welcome Peter to this meeting of SARC, and thank you very much for taking the time to speak with us. And I'll turn it over to you.
Thank you, Kevin, and it's a pleasure to be here with you tonight. The talk is titled "The Felicitous Union of Atmospheric Science and Amateur Radio." The Polar Environment Atmospheric Research Laboratory, monitoring the Arctic atmosphere, and Victor Yankee Zero Echo Romeo Charlie, the Eureka Amateur Radio Club. I'm the site manager for PEARL. I'm located at the University of Toronto, and I'm Victor Echo 3 Kilo Tango Bravo. So I'll just do a brief, and probably skip through that pretty quickly. Brief introduction about me, introduction to what and who we are with the Canadian Network for Detection of Atmospheric Change and the Polar Environment Atmospheric Research Laboratory, where we are, what we do, and why we do it there. I'll give a brief introduction to Eureka and the Joint/High Arctic Weather Stations, known as JAWS and HAWS, location and history-wise, and a bit about amateur radio in the Arctic in general, and what does all of that have to do with any of this. So by way of introduction, I'm Pierre, I'm a ham, born in Guelph, as you heard. I lived for 17 years in Denver, Colorado, where I did my master's and my PhD. My XYL is Teresa. I have 3 kids. The oldest, Alex, is also Victor Alpha 3 Lima Mike Lima. You'll see him particularly in RIDI contests. I got a Bachelor Honors degree in co-op physics from Waterloo, and then, as I said, graduate work from the University of Denver, specializing in atmospheric spectroscopy. And I manage a project up on Ellesmere Island called the Polar Environment Atmospheric Research Laboratory. So I'd like to show this. This map is now out of date because First Air has been bought by Canadian North. But this map basically shows you all of the places you can fly to in the high Arctic. And there are 2 things that are not there. One of them is not there is Toronto, where I get on an airplane. And the other is Eureka, where I would get off the airplane. So it's a minimum of 2 days to fly from here to there. Commercial to Yellowknife or Resolute Bay, and then a charter aircraft beyond those points. If we leave on the charter from Yellowknife, that's 7 to 8 hours on a turboprop, and it's pretty loud and cold and often cramped. But recent aircraft have been somewhat nicer, so that's an improvement. Some interesting facts about the area. The sun is not visible from the 20th of October to the 20th of February. The sun is always visible from the 10th of April to the 29th of August. Those 2 things limit what bands we can use from a given time of year. But, you know, there's always someone who wants me to try 80 meters in July. That's not going to work. It's classified as a semi-arid desert region, and it receives less than 30 centimeters of precipitation per year. So there's a few pictures from the Ridge Lab, part of the Pearl facilities. That's the big red building. This building was built in 1993 by Environment Canada. In 2002, they decided they didn't have enough money to keep it running. So some of my colleagues here in Canada decided that they would find some money to keep it operating. And then eventually Pearl was born. The picture on the top right was taken a few days ago. So the light that you see there is from the headlights of the truck that drove up there. Otherwise, you can see that it's pretty dark. It's 2 o'clock in the afternoon. The bottom picture, that's the business end of the building, as I like to say, the roof where we have the instruments installed and our antennas. And it's, yeah, in this case, it's actually pretty clear of snow, but it can get quite snowy up there. This is our second facility that's part of Pearl. We call this the Zero Altitude Pearl Auxiliary Lab, an acronym with an acronym in it. It's built of 20-foot sea containers. You can see, hopefully you can see my mouse here. So there are containers on the left side and containers on the right side. And we built a structure in the center to provide us some more working area. So that's it during the night, and then during, but this was sometime in March in the lower right here. It's our third site, is the Sapphire, the Surface Aerosol Flux and Irradiance Extension. So the way these things go is you open a lab. That we started with the Ridge Lab, the big red building, and someone said, oh, you know, I'd really like to be able to make measurements down around sea level. So that's why we opened up Opal. And then someone else said, oh, I really like being at sea level, but I don't want to be this close to the buildings because Opal is very close to the weather station. So we built Sapphire, which is out in the middle of the tundra, not surrounded by anything. So it just goes to show you that when you do something, so there's always someone who would like a little bit more. So the container on the left here houses instrumentation. And then we have some down-looking radiometers on the ends of the stalks here in the center. They measure radiation, what we call upwelling radiation. So that's radiation emitted by the surface. And then over here on the right, we have a flux tower. That's a 10-meter tall tower. It's got instrumentation all along it at various altitudes to measure vertical movement of air, temperature at 3 or 4 altitudes, and does all of this in high resolution in time and in altitude. So at any one time, we have approximately 25, sometimes as many as 30 instruments making measurements. Our goal is to make state-of-the-art atmospheric measurements with the same equipment we would use anywhere in the world. So even down south in a very well outfitted laboratory, we would have the same kinds of instruments here. That's presented us with some challenges, but so far we've been able to do that. I don't expect you to read all of those, but that's just an indication of some of the things we have up there. Here's some measurements that might be of interest to hams. On the left, we have the images produced by what we call our meteor radar. It works at 33.4 megahertz, so just outside the 10-meter band. And what it does is it's a vertically firing set of Yagis. So there's one transmitting antenna and 5 receiving antennas laid out in a cross. And the blue dots that you see in here are reflections from the ionized trails of meteors. So it's the same kind of thing you would use for meteor scatter communications. And we watch those trails decay as the radar pulses hit it. And from that, we can determine what the winds are at somewhere between 80 and 100 kilometers of altitude. So you can see the distribution of meteors versus height here. And then on the top graph, that's just the kind of a bar plot of the daily meteors. On the right, we have an all-sky imager. And one thing that many people are surprised by is that we rarely see aurora because we are right in the middle of the aurora oval, and the aurora is actually below our horizon. But every now and then, when the K gets up really high, we do see aurora, and you can see some here in this image here. Normally what this instrument does is it records all the light that comes down from the sky in the visible down into the UV, and then the visible is removed so that we can just watch the air glow and other UV signatures. But it makes for pretty pictures as well. So this is the work that I'm involved in. This is an infrared spectrum of ozone. So these are absorption features. So molecules, if they have a permanent or an induced dipole moment, as ozone does, as carbon dioxide and water vapor and many other molecules do, they will absorb the incoming radiation at the frequencies at which they are resonant. So very much like our antennas do, they're essentially the same thing. And so by calculating the area that is encompassed by one of these features here, we can deduce the amount of ozone that is in the path between us and the sun. And by carefully modeling the atmosphere and understanding what the pattern, so this pattern, all these line patterns here are driven by pressure and temperature, we can then calculate the distribution in the atmosphere. So molecules that are located high in the atmosphere result in a very narrow part of the line, so this part down here. And then the molecules that are lower in the atmosphere tend to have a broader signature and are represented by this portion of the spectral feature here. So our operations and communications in normal times, which is to say pre-COVID, we would have an operator on site 11 months of the year. Up until 2012, that was 365 days of the year, but funding cutbacks meant that we had to cut back our on-site time as well. But COVID has stopped that for the moment. Hopefully this year we will get back to that, but that remains yet to be seen. We had the world's most northern geostationary satellite ground station from Eureka at 80 degrees north. Anik F2 and other geostationary satellites are 1.5 roughly degrees above the horizon. So in order to make that work, we actually have to mount the dishes upside down in order to have enough travel, because the dishes don't typically have enough travel to go pretty much vertical. That gave us internet and VoIP phone service, but it's very expensive and very limited bandwidth because of that cost. We had a very high latency. It's somewhere around 600 milliseconds. That's the time to go from the ground to the satellite back to the ground again. And we used something called a vertical diversity system, which, as the atmosphere sometimes scatters the incoming beam from the satellite, what was discovered back in the 90s was that if you had two dishes separated by 50 to 100 meters in altitude, that if you lost a signal on one dish, you almost always picked it up on the other dish. In fact, the first year we were up, we had a downtime of 39 seconds throughout the year. That's the amount of time we lost with no signal on either dish. Recently, last August, we went with a low Earth orbit Galaxy OneWeb system. That costs us a lot less and gives us about 100 times the bandwidth. Unlike Starlink, which everybody talks about, the Galaxy system has 2 dishes inside radomes, and so they both track a satellite, and then they swap between them whenever the signal starts to decay too much on the other one. On the first one, it switches to the second. The first one picks up a second satellite or a third satellite, and they just hand off between them. This has allowed us to do a lot more remote operation because under the C-band system, it was really tough to run something like a remote desktop system or TeamViewer or anything like that. But now we're able to do that with without any problem. So why do we have Pearl? Well, the polar regions play extremely important roles in global atmospheric circulation. You've all had your share of weather out there this year. You know, there was a recent polar vortex intrusion in this part of the country also. So everything that happens up there impacts climate, weather, and atmospheric composition in the rest of the world. It's not surprising that they are very much undersampled because the sampling tends to happen where there are people, and there are very few people in the Arctic and the Antarctic. So understanding what's happening in the polar atmosphere is critical to understanding and therefore protecting the global atmosphere. And our best way to measure the atmosphere is to put state-of-the-art instrumentation where it needs to be, hence the instrumentation we have at Pearl. And of course, visiting the Arctic has many important benefits, sovereignty not the least of those, but also just the availing ourselves of the natural beauty of the area. So I'm often asked, well, why don't you just use satellites? Well, we do use satellites, but you know, Pearl measurements and ground-based measurements in general are complementary rather than exclusive to the satellite use. And what's not well understood is that you don't really have a satellite measurement until it's validated against another known data set. So, you know, you build an instrument, you test it, you put it on a satellite, you throw it into orbit, and you hope that it works. It's not always the case that they do. So the validation of the satellites is very important. The other thing that happens is that that's not a kind environment up there. So the instruments age, and the response to light or whatever they're measuring changes with time. So you need to test that against a known quantity in order to appropriately track that. Now, you know, with the ground-based measurements, you can't apply a measurement from one point in time in space to other times and other places until you understand its context. And the satellite measurements with high revisit times and broad coverage allow us to do that. So the two really work together very well. So Pearl provides satellite validation, and satellites provide context for Pearl measurements. So Pearl is situated in close proximity to the Eureka Weather Station. So Eureka was one of the 5 joint Arctic weather stations established in the late 1940s by Canada and the US. The United States pulled out of that program in the 1980s, and the JAWS stations, as they were known for Joint Arctic Weather Stations, became known as the High Arctic Weather Stations, or HAWS. These were in Resolute Bay, Eureka, Alert, Isaacson, and Mold Bay. Since then, Isaacson and Mold Bay have both been closed. So far, Eureka, Alert, and Resolute have managed to stay open. Of those 3, Resolute has a community, so it will probably always stay open. Alert is at a military installation, so there's a good chance that it will stay open. And Eureka is neither. It has a permanent complement of 8 persons. That's the SPM, the station program manager, 3 weather observers, a cook, handy person, housekeeper, mechanic, a heavy equipment operator. These folks rotate in typically 3 months in, 3 months out. Because Alert is a military base, Eureka serves as basically the northernmost accessible location as a jumping off point for expeditions northwards. Now, as the climate has warmed and the sea ice has thinned, those expeditions have pretty much disappeared. We used to see 1 or 2 or more a year, but now the last few attempts basically haven't made it very far offshore before they basically have to be evacuated because the ice is too weak to be trusted. The Eureka Weather Station is also where myself and my colleagues stay when we are working at Pearl. So this is the current Eureka Weather Station main building. It was completed in 2006. And it houses the 8 permanent staff and has space for 40 or so transients, as they like to call us. Eureka is headed by the station program manager, and that's a position shared between 3 individuals that rotate throughout the year. The water supply at Eureka is snow melt, so the creeks run as the snow melts and water gets pumped into a lagoon. It's powered by diesel generators. They work well, but fuel delivery becomes a problem below -48 Celsius. You can get these kind of interesting pictures of slugs of jellied diesel fuel that clog the lines. It can house up to 48 transients. It's not inexpensive. For those of us that like to complain about our electrical power bill, here in Ontario, it's about 12 cents a kilowatt hour. Electrical power in Eureka is $1.05 a kilowatt hour. Fuel is $6.30 a liter. And the daily accommodation on top of those costs is $446 a day per person. What the weather station does is it provides hourly weather reports, aviation weather. It flies 2 radiosonde flights per day. It does 1 ozone sonde flight per week. And in addition, it will do special flights, usually ozone sondes, as needed for research purposes. And it does an ice and snow survey in the winter. For many decades, HF radio was the only means of communication to and from the JAWS and HAWS sites and other sites such as the DEW Line. It currently is out of favor even for emergency or backup comms because, as I was told, no one is listening. I demonstrated that's not the case, but they prefer what they call reliable comms, such as Iridium sat phones. If you've ever used an Iridium sat phone in the north, you find that it's not so easy to get an Iridium signal sometimes. But amateur radio has always been an important part of communications for the Arctic. In 2017, myself and John Gilbert, VE3CXL, and Alexei Tikhomarov, VE1RUS, the 2 fellows that I have been working with in Eureka in the amateur radio area, wrote a pair of articles for the Canadian Amateur. The first one is shown here. And that picture is from April 7th, 1947. This was the first crew at the founding of Eureka. Amateur radio at Eureka and other northern sites. Eureka was the home of the Northern California DX Foundation beacon known as VE8AT. But a couple of years ago, after COVID started up, that was moved south to Inuvik. And I think that it's going to stay there. That's not my decision. I didn't update that number. It says we've logged over 12,000 contacts, which is true. We're actually up over 15,000 contacts since 2014. And this, remember, is over periods of several weeks per year. We're not there all the time. There have been a number of operators and operations over the years, even not counting just those of us that are there with CANDAC, and operation from other JAWS and HAWS stations. People such as SARC VE3KTB has activated a lot of the Arctic islands, including Melville as VY0M. So we are not the first by a long shot in doing this. We're just the ones doing it now. You can see there the VE8MA card that dates back to the 50s, I believe. But this is not an easy place to work for a number of reasons. On this plot over here on the left, you can see the magnetic pole path. You know, it's we're quite close to it. Eureka is over here on this red dot. And you can just make out a series of small circles here. This is the geomagnetic pole. So the geomagnetic pole basically is the center of the auroral oval. On the right here, this is a aurora forecast from the Ovation Prime model. And you can see the oval represented very nicely here, and the location of Eureka and VY0ERC right here in the center. This guy, as you wouldn't be surprised, I don't think, can present us a lot of difficulties. I first operated from Eureka in February and March of 2014, after I finally got around to finding enough time after building up Pearl and other, you know, having 3 young kids. I got myself licensed here in Canada in 2014. If I were an American, ironically, I would have just been able to operate with my American call sign /VE3 or /VE3. But because I'm a Canadian, I had to have a Canadian license, and there just wasn't enough time to do everything. So here are some pictures from the first activation. I was inside this building here, located in this part, which is actually the old power shed before they built the current one. I was using a R5 vertical, which was mounted up on this mast here on the left. I would say it was probably 6-7 meters off the ground. I basically had to wear, I didn't have to wear my parka all the time, but I did have to wear my insulated pants and my -100C Sorels. And that wasn't enough to keep my feet warm. I also had to put down a piece of pink styrofoam, because this is sitting on the ground and it's, you know, somewhere well below zero. I did not have a power supply with me, so I ran off a series of 12-volt batteries, and I was using a MFJ tuner because the R5 had been up in a while and was not really in tune, and a Kenwood TS570. So shortly thereafter, I discovered that my friend and colleague, Alexei Tikhomarov, who was also part of our group, was also a ham. And Alexei had contact with John Gilbert. John was a actual radio man in Eureka in the late 50s. So he had brought a lot of perspective to what we were doing and when it happened in the past. Victor Yankee Zero Echo Romeo Charlie, or sometimes we say Echo Radio Canada, is the call sign for the Eureka Amateur Radio Club. So Alexei is the trustee. Membership is open to all at no cost. So if anyone is interested, an email to VY0ERC@gmail.com, and Alexei will add you to the roster of members. We are quite happy to receive donations of any kind, whether they be funds or equipment. Our amplifiers and some of our antennas have been donated to us. And this is me operating from our current location at the Ridge Lab. So the first operations were from the weather station, and now we've moved about 11 kilometers away to the Ridge Lab. And the interesting thing about being this far north is that you don't have to drive very far before you're in a new grid. So the weather station, for example, is in EQ 79, and the Ridge Lab is in ER 60. So here are some details on VY0ERC in the site. The picture here is of our ultraviolet dial laser. So this is an ozone measuring instrument, and you can just make out our Moxon rectangle for 20 meters illuminated here to the right. So it's nothing terribly fancy. We have a single radio. We're currently using a Kenwood TS480HX. We actually have two amplifiers, the electronics, which is a single tube 3-500, and we have an NCL 2000, which has got two ceramic tubes, which I think are 8812s or something like that. The 20-meter Moxon is a homebrew antenna. We have an R5, Cushcraft R5 for 10 through 20, and a AP8, I forget who makes that, which is another commercial antenna that we use for 40 and 80 meters. As I've been saying, it's located at the Ridge Lab. So this puts us in CQ Zone 2. And we're in ITU Zone 75 because we're north of 80 degrees. Ellesmere Island is IOTA North America 8. The grid for the Ridge Lab is ER 60. The constraints are that we cannot cause any RFI to the instruments that we have on site, and we have to accept the RFI from the instruments, and there is quite a bit of that depending on what exactly happens to be operating at the time. We can't be in the field of view of any of the optical instruments. So most of the times we've been limited to 40 meters and up. We do have that AP8 for 80 meters, but it hasn't been very satisfactory. And the really sad thing is that we have to put the antennas up when we get there and take them down. Anything we leave in place does not survive. So our operating modes, sideband, RIDI, the digital modes, FT8, JT65, Whisper. We've done a little bit of PSK31. We're doing more and more CW, and we're doing more and more FM and linear satellites. Because it's easy, sideband is about 80% of what we do. And again, I missed updating that. We're at over 15,000 QSOs from Eureka. Some of you may have gotten one of our cards. That's our one of the local Eureka Wolfpack there, silhouetted against the sunset. We have the opportunity to combine science and amateur radio through HAMSci, which is a citizen science organization that brings together amateurs and scientists. You can read about them at hamsci.org. So Glenn and Gwyn and Bill, Rob, and John, those call signs there, are all part of this project, where we're basically listening to whisper reports using a loop on the ground with a preamp developed by Glenn. It uses a pair of Kiwi SDRs. And the idea is to gain an understanding of traveling ionospheric disturbances and the ionosphere in general by basically studying reception reports and propagation. We're also hosting a whisper beacon supplied by Roland, HB9VQQ, although that's been offline for a bit. We think with an antenna problem. We can't actually see what's going on, so we need to be able to figure out what's going on there. You can see here, this is a snapshot from 24 hours from basically 2 o'clock on February 6th to 2 o'clock or 2 p.m. Eastern. So what would that be? 1700 UT on the 6th of February to 1700 UT on 1900 UT on February 7th. So we are getting signals from certainly all over North America and Europe, a little bit from Africa and Asia and Japan. We have actually seen signals arriving from as far away as Antarctica, but they tend to come once the sun is up and the higher bands open up a little bit more. In addition to having to deal with being inside the auroral oval, the weather is a real problem. So that's the R5 there on the left. We now claim to have the strongest R5 on the planet because of the number of tubes that we have used to rejoint the antenna. So most of the antenna is actually double thickness now, because wherever it breaks like that, we cut the aluminum back and we slide an inner sleeve in and then reassemble it. You can't really see it here, but back here is a twisted mess that is the Moxon that also basically perished in this ice storm. On the right here, we have a battery blanket around a rotator, which did keep it able to turn, but it was not easy to do. Ironically, most of the damage comes in the spring and summer. I first went to Eureka in 1994, and I would say that up till about 2010 or 12, I never saw water ice on surfaces. We would get frost, but never ice. But it has warmed up and the atmosphere has got wet enough that now we get ice forming. And that ice usually forms in the summer. So, we can have quite nice weather for a while, but then a storm will come in and everything will freeze up and it all comes tumbling down. There's another pair of images with the R5 has gone down again, and the Moxon as well. Same old story. The clouds come down to the surface, to the height of the ridge, and very quickly everything ices up, and it falls. So there's yet another twisted mess of a Moxon. And that's Alexei in the foreground and myself in the background rebuilding it. Fortunately, our hallway is just long enough that we can build it inside in relative comfort, the elements that is, and then reassemble it back on the roof. Clearly, antennas are difficult to put up and keep up. Lots of times, atmospheric noise dominates. So verticals, which suffer from being sensitive to man-made noise, which is often vertically polarized, tend to work pretty well. So we have, in fact, built a 40-meter four-square array, and we are continuing. We raised funds for that via a GoFundMe campaign, which is still active. Because, of course, now we have to do the upkeep on the antennas, and we're hoping to build an 80-meter system because we have lots of requests for Zone 2 on 40 meters and 80 meters, especially on 80 meters. But so far, we've not had a lot of success with the antennas we've tried for 80 meters. One thing that, that building is the tallest thing. There are no trees. It's very difficult to put up a tower because digging into the ground to plant it is not easy, and there's no guarantee it's going to stay where you put it if the permafrost melts or shifts a bit. And there's been quite a bit of that happening in the area lately. So there's a snapshot of our contest participation 2017 and 2018. 2019 would have been the same. 2020, of course, was COVID, and so we weren't able to go nearly as often. So we are fortunate in that the major contests happen at the same time, more or less, that the sun comes back. So we have what we call a sunrise campaign every year, where we study the photochemistry that's activated as sunlight returns to the atmosphere. So we're there, and we have antennas and a radio, so we get on for the contests. So that's the ARRLDX sideband and CW, CQ worldwide sideband, CQ-WPX sideband. We're typically not still there for the CW version. Then there's a couple of RIDI contests. Anyway, we have the opportunity to have some fun at that time of the year, and often we're also there for the fall contest, because that happens to line up fairly well with our sunset campaign, where we are there making measurements during the last days in which our sunlight is illuminating the atmosphere. So how do we do? Well, unfortunately, we're not like the other island expeditions. You know, no one is going to go to Ellesmere and win a contest. Propagation will almost certainly never permit that. So that's over 15,000 QSOs logged. Charles, Mike 0, Oscar, X-ray Oscar is our QSL manager. He's got a very, very nice site, and you can do the online QSL requests if you're ever looking for a card. In 2016, which was back at the height of the last cycle, we did pretty well for that area and part-time operation with the vertical, 500 plus QSOs, 500,000 points. In 2018, and this was not anywhere near the top of the cycle, probably right at the bottom of the cycle, we managed 1,000 contacts in CQ worldwide. We've done pretty well in the IOTA contests. Second in the 12-hour Island expedition sideband. Then third in the 24-hour version the previous year. Not that this is really much to brag about, but we do hold some of the section records for VE8 and VY1. According to CQ, VY0 is part of VE8. Oh well. And we did the first ever operation from Nunavut in the NAQP RIDI contest. So, you know, if you'd like to work us, we would really like that. How to do that effectively depends on the time of year. So polar night, we have, relatively speaking, a small signal, so we're hard to hear. And ironically, we don't, if someone does hear us, we don't often get spotted. The best band by far is 20 meters. It works day and night, and has better reach than 40, probably in part because of the antennas that we can put up. Our best operating time during polar night is between 17 and 21 UT. That's on 20, also on 40, and 40 will be later. And during contests in particular, people always want us to move to 10 meters to see if it's open. And well, it's not open. 15 meters sometimes is open right around sunrise and sunset. During the day, our signals tend to do much better. 15 meters will be open, well, at the height of the cycle, maybe all day for us. And 40 meters is not typically available at this point in the cycle. Right at midnight local time, we can sometimes make a few contacts to the south, but really not much. 10 meters at the height of the cycle will be open, but 20 meters still rules. Having VY0ERC is only possible with the cooperation of many. First and foremost, Alexi and John, our principal investigator, Jim Drummond, the staff of the weather station, my and Alexi's XYLs and family members, and you guys. You know, if you guys weren't interested in talking to us, then there wouldn't be a lot of point in us doing this. So I'm going to say thank you for the opportunity to talk and for your attention. And I have a few slides here following showing things of interest and beauty. So if you guys want to start asking questions as I page through these slowly, I'd be happy to entertain them.
Well, that was really quite interesting. Had no idea you folks were up there and doing these sorts of things. You may have mentioned this when I didn't catch on it, but each time you go in, are you just going in twice a year? And how long are you staying each time, or how often is that, you know, are you up there?
I am generally there, again, I'm going to talk about normal times, pre-COVID. I am generally there 3 or 4 times a year.
Okay.
So typically I will be there from mid-February to early April. Then again in kind of late June through mid-July, sometimes all of July, depending on what needs to be done. And then again in October, from around the middle of October to the middle of November. We'll sometimes go in, you know, a time or two beyond that if there is some need, but generally 3 times a year is pretty typical.
Yeah. Okay. Thank you.
We've got a question from the audience here. From John Hummel Newell. Question about the movement of the magnetic pole. How much did this affect your operating? He was involved in tracking that movement in Baker Lake, Nunavut in the 2000s. And his mic is not working. So. Yeah,
I don't know. I mean, I can't tie anything directly to it, simply because, you know, it's been moving. But we haven't been there that long, so we don't really have anything to judge it against. So I can't really say that it has bothered us a lot, but on the other hand, it may have. We don't have anything to compare to.
I find it really interesting, all the acronyms. Do you guys actually sit down for a while and try to come up with the best acronyms for all of these things? It's pretty amazing to see them.
Yeah, in fact, the kind of golden rule is that you want an acronym that that you can pronounce as a word, but that isn't a word. So, for example, Pearl is not a very good acronym because there are things that are pearls. Mm-hmm. Kandak is better because you can say Kandak, but there isn't a word that is Kandak. But my favorite one is the International Arctic Systems Observing the Arctic Ice. How's that? It's basically ISOA, but it also stands for I am sick of acronyms.
Yeah. Are these photos that you've taken yourself?
Yes.
And what time of year would that be?
This is August.
Okay. Very nice.
Yeah, I have a question on the temperature range. Like in the winter, in the summer, what kind of ranges do you see? Is it so cold in the winter that you can't work on antennas, or do you the antenna breaks and you have, do you go out and try to repair it when it's, minus 100 or whatever it is? Probably not.
So winter temperatures at the Research Lab where we have the station are typically between minus 35 and minus 45. It is possible to work in those temperatures. You have to be careful with what you're doing. You have to be you have selected the wire with the right jacket on it, for one thing. If you have basically just your standard PVC insulated wire at minus 45, after 15 minutes or so, that insulation flakes off the wires if you move them. If you don't touch them, they're okay, but if you move them, it comes off. So you need PTFE based insulation. The coax sheath seems to be okay. We've never had a problem with that. It gets very cold very quickly holding on to, your mast or your boom or something like that. So we, we've got double gloves, and, we tend to think carefully about how we're going to put something in place and then try and get it in place as quickly as we can. The wind tends to be the biggest problem to deal with in the winter in particular. It's the case often that if it's windy, it's warmer. So you'd like it to be a little warmer so that, you can deal with the metal a bit better, but that'll mean that the wind is up, and, trying to lift an antenna into a sustained, 25 or 30 knot wind is, well, it's not safe for one thing, and not pleasant at all.
I would imagine you go outside in teams, or you go out, you kind of, if you're working in that kind of environment, you're not out very long and you've got someone with you.
Yeah. We have fairly strict protocols on, on that. For example, we don't, below 10 knots, we keep, basically, you just have to tell us that you're going outside. Above 10 knots, then one of us has to go with you. By one of us, I mean the operations staff that are experienced in being there. And then above 20 knots, we don't go outside either unless we really have to. And this is particularly for working on the roof of the building. It's not so bad if you're on the ground, but we have all of us been caught by a surprise gust, and not the best of positions, close to the railings on occasion. And fortunately, it's never been anything more than something to talk about. But we are very careful about that.
Yeah. Okay. Any other questions for Pierre?
Yeah, I've got one. It's Gord. I just, as you were talking, you talked about the satellite system and the latency which you were dealing with. I guess, was it the Iridium compared to what you have now? And you made a comment comparing it to Starlink. So just a question about that. And then you talked about you had to mount it upside down.
Yes. Yeah, so that's the C-band satellite. The C-band system, basically, you have to buy transponder space. So the organizations in the world that buy transponder space are things like national governments and multinational banks. So it's it's very expensive. So we have 3.4 meter dishes for the C-band, and their adjustment is only good down to somewhere around 10 degrees. So by turning it upside down, we were able to tilt the dish so that I could get down to that 1.5 degrees it needed to get to.
Okay.
But it also meant that the feed horn was then, I don't know, what, 6 meters off the ground.
Yeah.
Are most of your contacts evenly distributed around the world, or you mentioned south was very popular? Is that like the east coast of the U.S. or?
Yeah, we have a lot of contacts through the east coast of the U.S., the U.S. in general. A lot of contacts into Europe. If conditions are good, we seem to be very loud in Europe, and those pileups can be quite unruly. Much of southern Canada seems to be in the middle of a hop, so the Americans can hear us, but you know, the guys here in VE3 and perhaps you guys out there too, we seem to be shooting over your heads in a lot of conditions. You know, we've managed contacts into Africa, Mongolia, worked into Antarctica a couple of times. The interesting thing is that, you know, especially during the summertime when the sun is up 24 hours, when the conditions are good, we can, you know, basically just work around the world because we're always sunlit. And you know, if the band we're using is open to another area, we can usually reach it.
Okay. Great.
I have a question about the moon. I'm an EME operator. So, what kind of moon passes? Like, what kind of altitude do you get? What's the maximum altitude that the moon would be at from up there?
20, somewhere in the mid-20s, maybe as high as 30 degrees. I would really like to try some EME stuff, but I just haven't been able to pull together the equipment to do that yet.
Yeah, that'd be fantastic. Boy, oh boy, the EME community would, that's a really, really rare grid.
Yeah, and I mean, when the weather's good, we see the moon 24 hours a day.
Pierre, what is the easiest way to find out when your station is active and on the air? You know, if we want to make a concerted effort to work you, how do we find out sort of when you're going to be active and on the air?
We update the VY0ERC QRZ page with that information when we're going up. There's also a Twitter account for VY0ERC at VY0ERC. There's my own Twitter account, which is at Pierre_Fogal. And then Alexi's Twitter account, although that maybe not so much now that he won't be going up. So yeah. And we also send announcements out to like the DX News sites.
Okay, thank you.
So we try really hard to make it known that we're there. We're hoping to go up come early to mid-March, and I think that by the time we get there and get an antenna up, we might be there for the CQWPX sideband contest, and you know, whatever minor contests are around being held around that time. It's between the amount of work and the time of year. It's going to be tough to do much more than that.
Yeah, I see the WPX sideband contest is on March 25th and 26th. So
yeah,
there's the Commonwealth contest on March 11th to 12th, but that's maybe too early for you.
Well,
and that's a CW contest.
Yeah, I've done that the last 2 years that I was there, but it's at the moment I'm not sure that we'll be there by then.
Okay, well, you'll let it be known if you are probably, so
Yep.
we'll watch for that. Thank you.
Yep.
I have one other question. Actually, it's about the environment, things that we hear about in the news, and you're like with the talking about the hole in the ozone opening, and as well, you know, the issue of a grand solar minimum versus you talked about the moisture coming in and building on the antennas and creating ice. So is the fact that with the climate change that's going on, the sea ice and stuff is building, or is it still shrinking? And how does the whole research with the ozone fit in?
Well, the global sea ice coverage is continuing to shrink. I don't recall offhand what the numbers are for this past winter and spring. Okay. But the previous years, you know, it's been shrinking every year. The ozone hole, we had quite a good one in 2020, but good, I mean, a very noticeable ozone hole in 2020, and previous to that in 2011. In both cases, we were fortunate enough to be in place to be able to measure that. You know, the ozone destruction continues to happen, and the Montreal Protocol that was put in place to control CFCs has improved that significantly, but that's still, you know, an ongoing annual event to a greater or lesser extent.
Okay, thank you.
Yeah.
We have one more question from the chat here about, do you strictly fly in there, or do you have a sea lift to bring you goods and supplies?
There is a sea lift that comes in late August. That's for goods and supplies. We've never put any people on that. And so large things come in on the ship, but you know, produce and perishable food are all flown in.
All right, Pierre, thank you very much for coming and sharing your experiences with us. I found it very interesting. I think most people did. So it was really good. Thank you very much.
It's a pleasure, and always happy to do a talk.
Yeah.
But you probably don't want to hear me again too soon.
Well, I'm thinking like March, whatever that date was in mid-March. We're going to try and work you.
Yes, absolutely, absolutely. Try and work us. Yeah.